Alright, so starting off, we got y equals negative 2x squared plus 8x minus 5. And we're asked to graph that. So the first thing we got to do is find the x value of the vertex. And the x value of the vertex is negative b over 2a. So if we look at the equation, we identify a, b, and c. A is negative 2, b is 8, and c is negative 5. So if I'm negative b over 2a, that makes it negative 8 over 2 times negative 2, or negative 8 over negative 4, which is going to reduce down to 2. Then once we've got the x value of the vertex, we plug that in to solve for the y value of the vertex. So we're going to say y equals negative 2 times 2 squared plus 8 times 2 minus 5. So that's going to be negative 2. 2 squared is 4. Plus 8 times 2 is 16 minus 5. So y equals negative 8 plus 16 minus 5. And add those together. Negative 8 plus 16 is 8. Minus 5 is 3. So that gives us that our vertex is the point 2, 3. So we can start by graphing our vertex point. So 2 on the x, up to 3 on the y. Starts us off there. Remember, the graph of a quadratic or parabola is symmetric, so we can have a line of symmetry, which is the line x equals 2 here. And so everything on one side is going to mirror onto the other side, so we just need to calculate the points for 2 of the x values on either one side or the other of that axis of symmetry. So since our axis of symmetry is at 2, I'm going to use positive 1 and 0 as my x values to plug in. So I'm going to plug those into the equation, negative 2x squared plus 8x minus 5 to get my y value. So we use 1, so that's negative 2 times 1 squared plus 8 times 1 minus 5, or 1 squared is just 1, so negative 2 times 1 is negative 2 plus 8 minus 5. So negative 2 plus 8 is 6. 6 minus 5 is 1. So that gives me the point 1, 1. And then if I use 0, I've got negative 2 times 0 squared plus 8 times 0 minus 5. And everything is going to become 0 except for the negative 5 there. So I've got the point 1, 1 and the point 0, negative 5. If I plot those, 1, 1 goes there, 0, negative 5 goes here. And then whatever I do on one side of that axis of symmetry, I can mirror on the other side. So I'm at 1 to the left of the axis of symmetry here, so I can move over 1 to the right and mirror it. Take that point. And then down at negative 5, I'm 2 to the left, so I'm going to go 2 to the right. Put me somewhere right about there. And then I can draw in my parabola there. And the next one, another graphing, y equals x plus 3 squared plus 1, which when we look at this, this is in vertex form, which remember vertex form is y equals a times x minus h squared plus k, and the vertex in that format is the point hk. So I can get my vertex straight off of the equation. So my h and my k, h is going to be in there with the x, and it's the opposite sign of whatever's in front of it. So that's, instead of a positive 3, h is negative 3, and then k is just whatever's added at the end. So, and 1. So my vertex is going to be the point negative 3, 1. So I'm starting out at the point negative 3 on the x, positive 1 on the y. And so then from there, once I've got my vertex, it's just like the other one. We're going to pick 2 points on one side of the axis of symmetry, that line that goes through the vertex. And so I'm going to go to the right and use negative 2 and negative 1. So if I plug in negative 2 into x plus 3 squared plus 1, that's going to be negative 2 plus 3 squared plus 1. Negative 2 plus 3 is 1, so we got 1 squared plus 1. And 1 squared is just 1, so 1 plus 1 is 2. Or y. And do the same thing with the negative 1. So negative 1 plus 3 squared plus 1. It's going to be 2 squared plus 1, where 2 squared is 4, so 4 plus 1 is 5. So at negative 2, we're at 2. And negative 1, we're at 5. So at this point, we got 2 points to the right of the vertex, or the axis of symmetry. So now we're going to mirror those to the left. So mirror that one and that one. Drawing my parabola, and it looks something like that. Alright, 3, got y equals negative 1/3, that's x plus 1, that's x minus 5. Alright, and this one is in intercept form, which is y equals a times x minus p, x minus q. And when it's in that form, we know that we've got x-intercepts at the point P0 and the point Q0. So we're able to pull out P and Q and have 2 points on the graph real quick. So our P from that equation is going to be right where we got x plus 1, and it's, since it's x minus p and x minus q, the p is the opposite sign of what it is in the equation, and the q is the opposite sign of what it is in the equation. So it's plus 1 for, that's going to make my p negative 1, and my q is negative 5, or it's negative 5 inside there, so it's going to come out as a positive 5 for Q. So I've got the point negative 1, 0, and the point 5, 0. So if I plot those points on the graph, negative 1, 0, here 5, 0, be there. And then the vertex we know is halfway between those 2 points. So if I count, that's 1, 2, 3, 4, 5, 6 spaces between those 2 points. So half that distance would be 3. So I'm going to count over 1, 2, 3. And I can draw my axis of symmetry through that x value. So I know my axis of symmetry is at 2, which is halfway between those 2 points. And that also tells me that my vertex is on that line somewhere. So for my vertex, the x has to be positive 2. So now I can plug that in. Y equals negative 1/3 times 2 plus 1 times 2 minus 5. So y equals negative 1/3 times 3 times negative 3. Negative 1/3 times negative 9. It's going to be 3. So that means my vertex is going to be the point 2, 3. So up to 3 on that axis of symmetry. And on these, I let you graph those with just those 3 points, 2 intercepts in the vertex. So draw our curve through those 3 points, and we've got a graph. So then 4 just asks us to take y equals 2 times x plus 3 times x minus 4, write it in standard form, which means we've got to start off by foiling the x plus 3, x minus 4 portion. So it's going to be y equals 2 times x, which is x squared. The outsides, x times negative 4 is negative 4x. The inside terms times each other plus 3x. And then the last terms times each other, 3 times negative 4, negative 12. So that's 2 times x squared minus x minus 12. And to get it in standard form, I go ahead and I distribute that 2 from the outside. So we get y equals 2x squared minus 2x minus 24. Standard form. So then 5x squared minus x minus 20 just wants us to factor it. So there's no number in front of the x squared. So we look at that last term, negative 20. And find all the factors of negative 20. So since it's negative, you get one's positive, one's negative. So we got negative 1 times 20, or 1 times negative 20. 2 times negative 10, or negative 2 times 10. Negative 4 times 5, or 4 times negative 5. Looking for the combination that I can add together and equal the number in front of the x in the equation, which there's nothing there except for a negative sign, so we assume that's negative 1. So looking for the 2 numbers I can add together and get negative 1, which would be 4 plus negative 5 equals negative 1. So now I can write that as x plus 4, x minus 5. Just combine each one of those factors with the x. 6. We got 9x squared plus 6x plus 1. So if we look at this, so look at the first term, it's a 9, which is a perfect square. Last term is a 1, which is a perfect square. So we got two perfect squares. So that's the same thing as 3x squared. And the last one's like 1 squared. So we can check to see if it's a perfect square binomial by seeing if the middle is 2 times this term times that term. And so 2 times 3x times 1 would be 6x. So since it's a perfect square trinomial, we take the leading term and the end term and combine them. We look to see what the signs are. Since it's plus plus, that means there had to be no negative there. So it becomes 3x plus 1 squared. Next one, we got 12x squared minus 75. We just have two terms there, so we can't factor that in. We check to see, are they perfect squares? 12 is not a perfect square, 75 is not a perfect square. But then I look and I can say, well, both terms are divisible by 3. So I can pull the 3 out, and that'll leave me with 4x squared minus 25. And once I do that, now I look at those two terms that are separated by a subtraction, and they're both perfect squares. 4x squared and 25. So 4x squared is the same thing as the term 2x being squared, and 25 is the same thing as 5 squared. So that's an a squared minus b squared format, which we know, or should know, is factors to a plus b, a minus b. So that's going to be 2x plus 5, 2x minus 5. It's called a difference of two squares. And 18 wants us to write, or not 18, 8, which shows on 18. All right, 8 is y equals x squared plus 10x plus 24, wanting us to write it in intercept form, which basically means let's factor it, because intercept form is in y equals a times x minus p times x minus q. So that's going to give us y equals, we're going to factor that 24, looking for the factors of 24 that will add up to equal positive 10. And 6 times 4, if we add those together, it'll be 10. So that factors to x plus 6, x plus 4. Then 9, we've got the square root of 500. And it wants us to simplify. So 500 by itself does not have a perfect square root. But if we look at the factors of 500, that's 5 times 100. And 100 has a square root, which is 10, right? 10 times 10. So the 10s will come out, and that leaves us with a 5 behind under the radical. So that gives us 10 square roots of 5. 10 is the square root of 8 over 3, which is the same thing as the square root of 8 over the square root of 3. And so in order to do this one. 8 is the same thing as 4 times 2. All right, that's the square root of 4 times 2. And 4 has a square root, which is 2, so the 2 can come out, leaving the other 2 behind. And we haven't done anything with the square root of 3 yet. But the one problem is we can't have a square root in the denominator. So we've got to take that 2 square roots of 2 over the square root of 3 and multiply top and bottom by the square root of 3. That's going to give me 2 square roots of 6. And when I multiply the square root of 3 times the square root of 3, the square root disappears, which is going to just give me 3. So I end up with 2 square roots of 6 over 3. And then 11, we're plotting negative 5 plus I, 4 plus 2I, and negative 3I on a complex plane. So on a complex plane, the horizontal is the real axis, the vertical is the imaginary. And so from there, if we plot those points, the first one is negative 5 on the real. The part without the I is the real part. So negative 5, 1, 2, 3, 4, 5. And then positive I, or 1I, so I go up to positive 1. So that's negative 5 plus I. And the other one is 4 plus 2I, so I go to positive 4 on the real. 1, 2, 3, 4. And then 2I, so up to positive 2 on the imaginary. So there. That's 4 plus 2I. And then the last one is negative 3I, so there's no real part, or we would assume that the real part was 0. So if I start at 0 on the real axis and go down to 3, 1, 2, 3. Puts my point right there, negative 3I. And 12 through 15, we're just writing these complex numbers in standard form. So 12, 3 plus I, plus 1 minus 5I. So we're just combining those, just like combining like terms. So we can say 3 plus 1 and positive I plus negative 5I. Combining those, so 3 plus 1 is 4, and I plus negative 5I is going to be minus 4I. $13, same idea, except for we're subtracting here. So negative 4 plus 2I, minus 7 minus 3I. And so we distribute that negative. So that's like negative 4 plus 2I minus 7 plus 3I. So negative 4 minus 7 is negative 11. And 2I plus 3I is plus 5I. Okay, number 14. We got 8 plus I and 6 plus 2I. And so that's just a multiplication, multiplying those two binomials. So we're going to FOIL. So first terms, 8 times 6 is 48. Outside terms, plus 16I. The inside terms, I plus 6, plus 6I. And then I times 2I be plus 2i squared. And combine our like terms, that gives us 48 plus 22i plus 2 times, remember an I squared is represented as -1. So 2 times -1, so 48 plus 22i, and 2 times -1 is -2. And 48 minus 2 is 46 plus 22i. We got a division. 9 plus 2i over 1 minus 4i. We have this. The issue is that an I is a square root of -1, and we can't have a square root in the denominator, so we got to get rid of that. And the way we do that is we multiply top and bottom by the complex conjugate, which just means the same term but with a different sign in the middle. So 1 plus 4i So on the top, we're going to FOIL that. So 9 times 1 is 9. 9 times 4i plus 36i. And in the inside terms, 2i times 1 plus 2i. And 2i times 4i plus 8i squared. And when we multiply the complex conjugates together, it's going to be the a term squared plus the b term squared. So that's going to be 1 squared plus 4 squared. So we got 9 plus 38i plus 8 times I squared. And remember, an I squared is -1, so replace the I squared with -1. We got 1 squared plus 4 squared, or 1 plus 16. So we got 9 plus 38i minus 8 over 17. And finish that up by combining the 9 and the -8. So we got 1 plus 38i over 17. Well, I'll take it there. You could go ahead and separate that out and get 1/17 plus 38 17ths and I, which would actually be more in the standard form, but I'll take it at the other one. Alright, so then 16, we're looking at completing the square. They give us x squared minus 4x plus c. I don't know what the c value is that makes the expression a perfect square trinomial, and then we need to write that as a square of a binomial. So we know that c is equal to b over 2 squared. So if we look at the equation, b is in what's in front of the x. So our b is -4. So our c is going to be -4 over 2 squared, which -4 divided by 2 is -2. We square that, we get +4. So that's the c value that makes it a perfect square trinomial, which would be x squared minus 4x plus 4. And they want us to write that as a square of a binomial. And so the square of a binomial is x plus b over 2 squared. So our b term was -4 over 2, gave us the -2, so it's going to be x plus -2, or just x minus 2 squared. 17, same process. X squared plus 11x plus c. So our b here is 11. So c is going to be 11 over 2 squared. So 121 over 4. So it would be x squared plus 11x plus 121 fourths. So that's the c value. And then if we write that as the square of a binomial, it's x plus b over 2. So x plus, and the b over 2 was 11 over 2 squared. (18) wants us to write y equals x squared minus 6x plus 11 in vertex form. Remember, vertex form is y equals a times x minus h squared plus k. So in order to do that, we've got to have a square of a binomial. And when we look at this, ending in 11, that's not a perfect square, so we can't convert that into a perfect square trinomial or binomial unless we complete the square. And to do that, we're going to take the equation and we're going to slide the 11 over to the side, and we're going to complete the square with the x squared minus 6x portion. So x squared minus 6x, the b is negative 6, so c is negative 6 over 2 squared, or that would be negative 3 squared, which is going to be 9. So I'm going to take that 9 and I'm going to put it in with that as plus 9. Now the thing is, since we've got an equation and we're completing the square on one side, we're adding 9 on the right side, so what we do to the right side we also have to do to the left side. So now we're at y plus 9 equals x squared minus 6x plus 9 plus 11. And that x squared minus 6x plus 9 is a perfect square trinomial, which we can write as the square of a binomial. And the square of the binomial is x plus b over 2. So x plus b over 2 was, the b over 2 was negative 6 over 2, which is negative 3. So x plus negative 3, or just x minus 3 squared, plus 11. And then move that 9 over by subtracting it. So we have y equals x minus 3 squared plus 2. Mm-hmm. 19, x squared minus 36 equals 0. And we're going to solve the quadratic equations by the method given, and the method given here is factoring. So if we factor that, we look at it, it's two terms separated by a subtraction, so we check to see if they're perfect squares. And x squared is the same thing as having x squared minus 36 is a perfect square. That's 6 squared. So that's an a squared minus b squared format, otherwise known as a difference of two squares. And a difference of two squares factors to the a term plus the b and the a term minus the b term. So our a term here would be the x, the b term would be the 6. That's going to be x plus 6 times x minus 6 equals 0. And once it's factored, we set each one of the factors equal to 0. So x plus 6 equals 0, x minus 6 equals 0. Subtract the 6 from both sides, and we get x equals negative 6. And on the other one, we add 6 to both sides. That gives us x equals positive 6. So we have those two possible solutions for that quadratic, x squared minus 36 equals 0. 20, we got 3 times x minus 9 squared equals 81. And the method we're asked to use is square root. So first thing I'm going to do is move the 3 over. So divide by 3. So that gives me x minus 9 squared equals 27. Now we got to get rid of the square, so we take the square root of both sides. And when we insert a square root to solve, we have to put in plus or minus. So that leaves us now with x minus 9 equals plus or minus the square root of 27. And then we can move the 9 over by adding it to both sides. So now we have x equals 9 plus or minus the square root of 27. And then to be as simple as possible, we can simplify the 27 underneath the radical, which 27 is 9 times 3. And 9 is 3 times 3. So that means 9 has a square root, which is 3. So the 3 comes out. So x equals 9 plus or minus 3. And then there was 1 3 that stayed by itself. So 3 square roots of 3. So in 21, x squared minus 12x equals negative 28. I want us to solve this by completing the square. Alright, so we're completing the square. So from here, we got x squared minus 12x equals negative 28. And if we move 28 over, it's not a perfect square, so we're going to use the left side and call our b negative 12. So c is, remember completing the square is b over 2 squared. So it's going to be negative 12 over 2 squared, which would be negative 6 squared, which is going to give us 36. So we add that 36 to both sides. So x squared minus 12x plus 36 equals negative 28 plus 36. And once we've completed the square, then we know we can write that as the square of a binomial, which is x plus b over 2 squared. So x plus b over 2, our b over 2 is negative 6. So x plus negative 6, or just x minus 6 squared equals negative 28 plus 36, which is positive 8. To get rid of the square, we take the square root of both sides. Don't forget we have to put a plus or minus in there when we take a square on each side. That gives us x minus 6 equals plus or minus the square root of 8. Then move that 6 over by adding it. Add 6 to both sides. So x equals 6 plus or minus the square root of 8. Now all we've got to do is simplify under the radical if we can. And 8 is the same thing as 4 times 2. And 4 factors down to 2 times 2. So it's a perfect, 4 is a perfect square, so the 2 comes out, leaving us with x equals 6 plus or minus 2 square roots of what's left behind is 1, 2. So 6 plus or minus 2 square roots of 2. And then 22 gives us x squared minus 2x minus 4. And they want us to use the quadratic formula. And the quadratic formula tells us that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So don't forget the 0 there. So x squared minus 2x minus 4. I'm going to write that again because that's just sloppy. So x squared minus 2x minus 4 equals 0. And we're using the quadratic formula, so we have to identify a, b, and c. A term's in front of the x squared, which there's nothing there, so we assume that's a 1. B is in front of the x, which is negative 2, and c is the constant term, the number by itself, negative 4. And so from there, plug those into the quadratic formula. X equals negative b, so that's negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times the a, which is 1, times c, which is negative 4, all over 2 times the a term, so 2 times 1. And now it's just a matter of simplifying all that. So x equals negative 2 is going to be positive 2, plus or minus the square root. Negative 2 squared is 4, minus 4, negative 4 times 1 is negative 4 times negative 4. It was positive 16 over 2 times 1, which is 2. So that's 2 plus or minus the square root of 20 over 2, which that's just about it. All we do now is look to simplify that 20 under the radical, which 20 is 4 times 5. 4 has a perfect square root, which is 2. 5 can't break down any further, so it's going to stay behind as a 5. So we end up with x equals 2 plus or minus 2 square roots of 5 over 2. And then from here, if we look, you got 2 over 2, 2 over 2. So both of those terms can divide out by the 2, which is going to leave us with 2 divided by 2, which is 1, plus or minus 2 over 2 square roots of 5, or just the square root of 5. And 23 doesn't give us a way to solve it, so 2x squared plus 8x minus 24 equals 0. So the first thing I notice about all these terms is they're all even numbers, so I can divide both sides by 2. That's going to give me x squared plus 4x minus 12 equals 0 divided by 2, which is 0. And then I can, my preferred is to see if I can factor it, so I look at negative 12, see if there's any factors of negative 12 that'll add up to positive 4. So you got 1 and negative 12, or negative 1 and 12, 2 and negative 6, or negative 2 and positive 6, 3 and negative 4, or negative 3 and 4. I'm looking for the pair that adds up to equal positive 4, which will be negative 2 plus 6 equals 4. So that factors to x minus 2, x plus 6 equals 0. Now I can set each one of those equal to 0, so x minus 2 equals 0, x plus 6 equals 0. Add the 2 to both sides, that gives us x equals 2. Or we can subtract 6 from both sides on the other one and get x equals negative 6. So x equals 2 or x equals negative 6. So then 24 wants us to find the discriminant of 7x squared minus x plus 10 equals 0. And then what does it tell us about the number and type of solutions? So the discriminant is just the part underneath the radical of the quadratic formula, or the b squared minus 4ac part. So first thing we do is recognize our a, b, and c's. So a here is the 7, then b is what's in front of the x, which is -1, and c is the number by itself, which is 10. So my discriminant is going to be -1 squared minus 4 times 7 times 10. So -1 squared is +1, and minus 280, which is going to be -279. And so since the discriminant is a negative number, that means I've got two imaginary solutions. So that's a negative. 279 is the discriminant. Two imaginary solutions. Remember, if your discriminant is greater than 0, or it's a positive number, that means you have two real solutions. If it equals 0, then you've got one real solution. And of course, based on this one, if it's negative, you get two imaginary solutions. And then lastly here, we got number 25. Wants us to write these quadratic functions, in the form best fitting the information. So A tells us we got a vertex of -4, 6, and it goes through the point -1, 9. So they give us a vertex, so that should lead us to think of vertex form, which is y equals a times x minus h plus k, remembering that the vertex is the point hk. So since they give us a vertex, we know that the h value is the -4, the k value is going to be the 6, so I can plug those in and get most of the equation right off. Y equals a times x minus h, which is -4, and plus k, which is 6. Left off on that vertex form. That should be squared, x minus h squared. So that's going to simplify to y equals a times x plus 4 squared plus 6. And the only thing we don't know in order to have this equation is the a. So now we're going to take the other equation, or the other point they give us, and plug it in to that equation so that we can solve for the a. So the y is 9 equals a times x, which is -1 plus 4 squared plus 6. So the 9 and the -1 just came from that point that they gave us. Now we simplify it. So 9 equals a times 3 squared plus 6, or 9 equals 3 squared is 9, so 9a plus 6. Subtract 6 from both sides. So it's going to give us 3 equals 9a divided by the 9. And our a term is going to be 3 over 9, which reduces to 1/3. So now I can take that and plug it in for a in that equation that we just had. So our answer is going to be y equals 1/3 for a times x plus 4 squared plus 6. And then for b, they give us x-intercepts of 1 and 4. and goes through the point 3, 2. So since they're giving us x-intercepts, we should think of intercept form, which is y equals, make that look a little more like an equals. Y equals a times x minus p times x minus q, and p and q are the intercepts, so 1 would be p, 4 would be q, so that gives us y equals a times x minus 1 times x minus 4. And just like the last one, we got everything now except for the a term. So we take the point they give us and we plug it into the equation for x and y. So when we do that, our y is, no, not 3, y is 2. And then times, or equals, and messing this up left and right. So 2 equals a times x minus 1, the x is 3, so 3 minus 1, times x minus 4, so 3 minus 4. Or to simplify it, 2 equals a times 3 minus 1 is 2, 3 minus 4 is negative 1. So 2 equals, 2 times negative 1 is negative 2a. Divide by negative 2 to solve for a. And we get negative 1 is equal to a. So we take that and plug it in for the a in that equation that we had up there. So our answer is going to be y equals negative 1 times x minus 1 times x minus 4. Now you could, since that's a negative 1, just write it as negative x minus 1 times x minus 4. Either way. But that completes the review, and so hopefully you'll study this and be prepared for the test. See you then.